Hi, and welcome back to Algebra 1. Our goal for today is to continue to factor polynomial expressions, but for today, the polynomial expression is going to be bigger or more complex than a linear binomial. Please remember, a linear binomial means the highest degree is a 1, and it will have 2 terms. So for today, our highest degree might be a 2, or a 3, or a 4, or a 20. And we might have more than 2 terms. It might be a trinomial or a quadrinomial. So how do we go about factoring out our greatest common factor if the problem is bigger and more complex than a degree of 1 with only 2 terms? It's the same process, just with a bigger, more complex problem. So our steps for today really haven't changed. We're still doing this process of factoring, which is breaking our problem back up into things that could be multiplied to get back to the original item. So far, we've been working over here, where we have a degree of 1 and 2 terms, right? Which is the most basic, simplest, easiest thing to factor back apart. So for today, the problems are going to be a little bit more complex than that, right? So for example, over here, we have a quadratic trinomial, right? Where our highest degree is a 2, and we have 3 individual terms. So how would we go about factoring out our greatest common factor if the problem is bigger or more complex, right? So it's the same process of, in this case, they had a GCF of 5, and then what would be left over would be our sort of leftover in parentheses portion of our problem, creating still 2 factors. In this case, a factor of 5, and then a factor of 6x squared plus 3x minus 1. All right, so our steps for today, I'm going to find my greatest common factor. Again, if I need the tree in the chart to do that, and I can't just do it in my head, go ahead, do the tree in the chart, do your scratch paper work. Once you know the greatest common factor of all of your terms, you want to divide each individual term by that value to see what your leftover factor is. Right, you're going to have 2 factors, an outside factor and your leftover factor when you're done for today, because we are factoring out the greatest common factor of all the terms in the original problem. All right, so your number 1, we want to factor completely the quadratic binomial here, right? The highest degree is now a 2, and there's still only 2 terms. Our terms are 4x squared and negative 3x. If you can't see the highest common factor here, go to your tree, right? 2 and 2. And now we have 2 x's here, x squared, so be careful. And then over here, oops, sorry, this should be a 1, 2, 2, all right? Over here, negative 1 and 3 to get started, and then an x. All right, and this would have been a 4. My apologies. All right, from here, we can now make our chart real quick, right? Make a little sketch. Doesn't have to be perfect. This is scratch paper stuff. All right, so on the bottom, we have a negative 1. On the top, we have a positive 1. 2 2's, a 3 down here, 2 x's, and an x. So the only thing that these 2 have in common is actually an x. All right, so in this case, no number, just a variable x gets pulled out. Now, if you can see that by just looking at these, the thing that they have in common is 1x, go straight there. I'm okay with that. That's your scratch paper. All right, so we're going to divide each of these by an x, which means if I have x squared, it's going to eliminate one of these, right? It'll now be just an x. All right, so we have 4 and still 1x left over in here. Now, the other option is I still have my leftovers here. So 1 times 2 times 2 times x, right? And this one's gone, right? That's the other way to still get there. All right, we're taking negative 3x and dividing it by an x, which would eliminate this x. And we still have the minus 3, or negative 3. Again, down here, we'd say this x is gone, and negative 1 times 3, right, would be the leftover. All right, we've factored our quadratic binomial now completely by GCF. All right, number 2, 4h squared plus 6h. If you need your scratch, use it. Maybe this is one we can do without our scratch. All right, 4h squared and 6h. The highest number that goes into both 4 and 6 is a 2. And then this has 2 h's. This one has 1. So they both terms have at least 1 h. So we can pull that out. Now, if I just did that and you're going, wait, how did she see that? You are definitely a do your tree, do your chart person, which is perfectly acceptable. All right, go ahead and do it. All right, now we go to our leftovers. We're going to take these and divide them both by 2h. All right, Over here, 4 divided by 2 gives us a number of 2. H squared divided by h eliminates one of these two h's, right? Remember, we can check our work here. So 2h times 2h, would it give us that original 4h squared, right? Run your check when you're done to make sure it matches up. All right, 6h divided by 2h. So 6 divided by 2 would give us a 3, and then h divided by h would eliminate, right? We just have a plus 3 left over. All right, factored completely here. 2h times 2h plus 3. All right, number 3, we want to factor completely here. Negative 12m minus 8m squared. All right, if I can't look at it and see what to pull out, go over here, do your tree, do your chart. All right, that's perfectly acceptable scratch paper work, so do it. All right, maybe we could do this one without it, so let's look at it. They both share a negative, so the negative can come out front. And the highest number that goes both into 12 and 8 would be 4. And then this has 1m, this one has 2m, so they at least have 1m, right? So we can pull out a negative that they both have a 4, and they both have at least 1m. All right, let's think about our leftovers. We're going to divide both of these by a negative 4m. Boom, 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 boom. All right, negative divided by negative is a positive. So in here, we're going to have a positive. 12 divided by 4 is a 3. M divided by m would cancel, right? Run your check, distribute. Negative 4m times 3, would it actually give us this negative 12m? Yes, we're good. All right, go to your next one. Negative 8 divided by negative 4 would be a positive 2. And then m squared divided by an m would eliminate one of the m's, and we'd have 1m left over. Again, distribute and see if you're okay. Negative 4m times 2m, would it actually give us this negative 8m squared? Yep, we're good. It checks out. All right, number 4. Negative 15y to the 4th plus 4m squared. All right, I'm looking at this one saying they don't share a y. They don't share an m. They're not both negative, so you can't pull out a negative 1. Factors of 4 are 2 and 2. Factors of 15 are 1, 3, 5, and 15. They don't seem to have anything in common. So maybe I want to go over here and just double check my thought process. All right, negative 1 and 15, 3 and 5, and we would have 4 of these. Y. And then over here we'd have, I'll go 1 and 4 again, 2 and 2, and m and m. All right, and again, I'm like, oh, no, this seems like they're not matching up. So let me make a quick little table, make sure my mental thought process here is right. It doesn't seem like they share any common factors. All right, so on the top, a negative 1, on the bottom, a 1. On the bottom, 2 2s, on the top, a 3 and a 5, a bunch of y's, and a couple m's back here. All right. Now, none of the columns are shared by both numbers. So this is sort of a special case. I can't pull anything out. There's nothing I can pull out that when I would multiply it back together would give us this result. And it's a special case, which means that this problem is prime. Prime. I can't factor it by GCF. It is prime. All right, number 5. 10y to the 3rd plus 20y squared minus 5y. All right, so now we're getting a little bit more complex here. We have a cubic, because our degree here is a 3, right? That makes it a cubic. And then we have 3 terms, which makes it a trinomial, right? A little bit bigger, a little bit more complex. All right, we're looking for the highest number we could pull out of 10, 20, and negative 5. Since they're not all negative, we definitely can't pull out the negative sign. But we can pull out they're all divisible by 5. All right, so that's our number that we can pull out of all of them. Again, if I can't see that, I'm a tree chart person, which is fine. All right, now, this one has 3 y's, this one has 2 y's, and this one has 1 y, which means every single term has at least 1 y. That's what they have in common. That can also get pulled out. Again, if I can't see that, do your tree, do your chart. It'll help you. All right, now, here's where you need to be careful. I should have 1, 2, 3 terms. It's a trinomial. I should have 3 terms left over. I'm dividing each of these individually by 5y. So 10 divided by 5 is a 2. y to the third divided by y would eliminate 1y, so there's still 2 left over in here. All right, go to your 20y squared, do the same process. 20 divided by 5 is a positive 4. And then y squared divided by a y would eliminate one of the 2 y's, and we'd still have 1 left over in here. All right, negative 5 divided by 5 is a negative 1. So I could put the negative sign, or I could actually put a negative 1 there. And then a y divided by y would cancel, so it would look like so. 5y times 2y squared plus 4y minus 1. All right, number 6. We have a quartic trinomial because we have a degree of 4 and we have 3 individual terms and we want to factor it by GCF. All right, 8, 4, and negative 2. Again, they're not all negative, so we can't pull the negative out. But 2 goes into all of it, right? 2 goes into 2, 2 goes into 4, 2 goes into 8, right? So that would be our biggest number. All right, this has 4 x's, this has 3 x's, this has 2 x's. So they all have at least 2x. That's our greatest amount we can pull out here. All right, now we have a trinomial to start. So we're going to have 3 leftover things in here. So let's go piece by piece. 8 divided by 2 would give us a 4. X to the 4th divided by x to the 2nd would eliminate 2 of these x's, leaving 2 left over. All right, for x to the 3rd, 4 divided by 2 is a positive 2. And x to the 3rd divided by x squared would eliminate 2 of these 3 x's, leaving 1 left over on the inside. All right, negative 2 divided by 2 again would give us a negative 1. And then x squared divided by x squared would completely eliminate, only leaving the negative 1 on the inside. All right, you try your 7, 8, and 9, and 10. Try. All right, hopefully you have your answers done. Let's look at them. All right, for your number 7. All right, we have a negative 7x to the 3rd that can get factored out, all being multiplied with a 5x to the 5th plus 6. I've shown you your GCF scratch work there if you needed it. Negative 7x to the 3rd is your GCF factor that should have gotten pulled out. All right, your second one here. 2h is the greatest common factor. Factor that out. And we should have a 2h times 6h to the 3rd plus 4h plus 3. All right, our GCF here is a negative 3, and it's being multiplied with 12f plus 6f squared plus 1. It's your factored completely version. All right, I hope that helps you attack your work for today. I will see you guys later. Have a good one.